अनि एक्जाम्पल हामीले यसमा यहाँ पनि गरेको एक्जाम्पल्स यहाँ पनि गरेको छ हामीले अब यहाँ पनि गरेको छ एक्जाम्पल्स ल यो बाहेक अरु के छ सोध्नु पर्ने यसमा के छ सोध्नु पर्ने फर्स्ट यसमा त ए अर्को एउटा बाँकी छ मेजरमेन्ट एन्ड स्केलिङ छुटिरहेको छ मैले भन्नु पर्छ नि स्केलिङ यसमा nominal scale, ordinal scale, interval scale, ratio scale, and examples. Each. हामीले पढेको यति नै हो यसमा के क्वेशन छ ल भन फर्स्ट यसबाट जाऊ मेजरमेन्ट एन्ड स्केलिङ मा जाऊ न पहिला ल मेजरमेन्ट एन्ड स्केलिङ मा के कन्फ्युजन छ यस क्लास So, Jivraj, do you have any question or confusion?
No, sir.
No. Arsa?
No, sir.
Yes? Is a key question also confusion, sir?
Yes, sir.
Sorry, now, okay. Next one is Numa. He is not there. No.
No, sir.
Okay. Susan? Susan Mandari?
No, sir.
No. Pravesh Potrai?
No, sir.
Okay. Pratima Oli?
No, sir.
Samyo Gadikari?
No, sir.
No. Roshan Kuswa? Kumar Sawan? I think he is absent. Usha Sapota?
No, sir.
Okay, if you have any question, you can ask me. It is not possible to ask each and everyone. So if you have any question, you can ask me. Measurement and scaling. त्यसैले मलाई एउटा एकजना कसैले भन न त नोमिनल स्केलको एक्जाम्पल भन त ल एकजना कसैले नोमिनल स्केलको एक्जाम्पल भन त भोलिन्टियरले एकजना कसैले भनिन्छ खै त
Student in a class based on the sex.
Okay. Sex of a student, simple. I know. Male, female, that is the nominal scale. Very good. इन्टरभल स्केलको क्यारेक्टरिस्टिक्सहरु के हो त? कसले भन्न सक्छ ल भन? एकजना कसैले भन त? Main properties.
Can categorize the value of variable.
Yes, good.
We can keep those categories in terms of order.
Okay, good. Second.
And we can measure the gap.
Very good. Third one.
And true zero does not exist.
Okay, very good. What do you mean by true zero does not exist?
Like if we say IQ of a student, there won't be like zero IQ. There is some.
Okay, very good. Yeah, IQ हुन्छ. Next example. Temperature. Like 0 degrees centigrade. If I say the temperature is 0 degrees centigrade, it does not mean that there is absence of temperature. Okay, very good. Now, in case of nominal scale or say interval scale, if your data can only be measured by ordinal scale, can you find the product of the values? Whenever we measure the value of any variable, it will come either in terms of number or in terms of word. In case of ordinal scale, can you multiply the value of a variable? My question is, in case of ordinal scale, can you find the product of the value of variable? एकजना कसैले भन त ल. सबै बिर्छ हैन त? एक्चुअली क्लासको फर्स्ट क्लासको कपी हेर्नु त्यहाँ मैले लेखेको तिमीहरूलाई मैले नोट गराइसकेको छु. Only in case of ratio scale, we can find the sum, differences, product, and division. We can add, we can subtract, we can multiply, we can divide only in case of ratio scale. In case of interval scale, multiplication and division are not allowed. Only addition and subtraction are allowed. In case of ordinal scale and nominal scale, no, we cannot add, we cannot subtract, we cannot multiply, we cannot divide. We can only calculate frequency and percentage in case of nominal and ordinal scale. For example, say sex, male, female, we cannot add, we cannot subtract, we cannot divide, we cannot multiply, but we can calculate either frequency or percentage, ordinal scale. Similarly, in case of ordinal scale also, addition and subtraction as well as multiplication and division are not allowed. Only frequency and percentage can be calculated. In case of interval scale, you can add and subtract, but you cannot multiply and divide. And in case of ratio scale, you can add, subtract, multiply, and divide. Okay. Now, mean, median, mode, quartiles, discharge, percentile. You know all about this. We already discussed. So if you have any question, you can ask me. If you don't have any question, then I'll go through diagrammatic representation of data. This one is very, very simple. So I'll not explain in detail about this. Diagrammatic representation of data. In this diagrammatic representation of data, we will describe the data in terms of diagram and figure. And they are bar diagram, histogram, pie chart, frequency polygon, EOL polygon, and next one is actually that is bar diagram, multiple bar diagram, subdivided bar diagram, multiple bar diagram, subdivided bar diagram. Actually, these are the bar diagrams. Okay, now first one is bar diagram. In case of bar diagram, we will have x-axis, we have y-axis, okay. Now on this two-dimensional plane, this one is known as two-dimensional plane. This one is x-axis, this one is y-axis. Generally on y-axis we will plot frequency. We will plot frequency on x-axis. On y-axis we will plot value, variable. Suppose for example we have values like this one. Values of variable is like this one, say five to 9, and that is repeated say one time. It is repeated one time. We have next one is say 10 to 14, and it is repeated two times. So we have next 15 to 19, and it is repeated say three times. That means the only clear one. Okay, value. Variable, say 5 to 9. 5 to 9, it is repeated one times. Next we have 10 to 14, it is repeated say two times. 15 to 19, it is repeated suppose three times. Now look here, 5 to 9. Now here it is 0. Here it is 1, say. Here it is 2. So here it is 0, this one is 5, so this one is 5. This one is 10. This one is 15, like this one. And here are the corresponding frequencies. So this one is 1, this one is 2, this one is 3. Now here 5 to 9, 1, that means this one is 5, this one is 10. So here it will be like this one. 5, it is 1, repeated one times. And here next one. Like this one. Okay. This one is 5 to 9. And similarly, now 10 to 14. Here is 10, you know is 10. 10 to 14, that is 2 times. Okay. Okay. Let's remember also. Now here one important thing you should note it. Here, if there is gap between the bars, there will be gap between the bars in case of bar diagram. Look at here is 5 to 9. So here this one is 5, this one is 9, and here is 10 to 14. So between 9 and 10 there will be a gap. This is the main characteristics of bar diagram. These adjacent side, although these are not adjacent side, but if you say these two are adjacent side, then they will never toss to each other. It will be like this one. Okay, on bar diagram. Now opposite histogram or in case of histogram, all these bars are attached. That means the adjacent side are attached with each other. So this is about bar diagram. This one is histogram. Bar diagram is especially useful if you are dealing with nominal and ordinal data. Like sex, occupation, religion, types of disease, etc. Those types of data are measured by using nominal data. So you will use bar diagram to represent such type of data. And histogram is useful for continuous data. Suppose you have data like this, 0 to 5, 5 to 10, 10 to 15, 15 to 20. On such case, you will use histogram. Now pie chart, you know what is pie chart? It's very, very easy. मलाई लाग्छ क्लास कति 5, 6 कतिदेखि बनाउँछ नि आज. Okay, this is a circle. And it will be like this on pie chart. Based on the number of categories, there will be slices. If you have just 2 categories, 2 slices. Okay. If you have 2 categories, then 2 slices. This is 1 slice. And this one is another slice. If you have more than 2 categories, you will have more than 2 slices. For example, if you have 3 categories, you have 3 slices. If you have 4 categories, you have 4 slices. If you have 10 categories, you will get 10 slices. So, as the number of category increases, it will be confusing to study your pie chart. It will be difficult to observe. So, we will recommend you to prepare bar diagram or histogram instead of pie chart. Okay. Our next one is frequency polygon. Now, in case of frequency polygon, first of all, you will prepare histogram like this. Okay. यहाँ तलसम्म जोडिएको हुन्छ यो Okay, now this one is a histogram. Okay. Look here, on the top of the bars of this histogram, identify the mid value, midpoint. Suppose these are the midpoints. This one is the midpoint, suppose. This one is the midpoint. This one is the midpoint. This one is the midpoint. And now, join all these points by smooth hand, freely, join freely. Join all these points by smooth line, like this. Although it is not a smooth one, here also it will come in this way. Okay. Now, this is known as frequency polygon. This curve is known as frequency polygon. This curve. And if you use frequency polygon to represent your data, it is not necessary to prepare this histogram. By using software, you can directly prepare frequency polygon. But if you are preparing your frequency polygon manually, then on such a situation, you have to use, first of all, you have to prepare histogram and then add all these midpoints to get the frequency polygon. Okay. So on a single two-dimensional graph, you can prepare multiple frequency polygons. You can prepare multiple frequency polygons. Okay. This first is for one set of data. If you have another set of data, this. If you have third set of data, this. So if you prepare histogram for different set of data, it will be confusing to study, to observe. But if you use frequency polygon, it will be very, very easy to observe all these 3 frequency polygon or more than 3 or 100 frequency polygon on a simple single 2-dimensional graph. This is all about frequency polygon. Now next one is multiple bar diagram or subdivided bar diagram. In case of subdivided bar diagram, you have a bar like this, bar diagram like this. And the same is divided on multiple bars like this one. Okay. You know all about these things. So I suggest you to study yourself. Yeah? Or say homework. This is all about our course. Now we covered the entire part of the course. So if you have anything to ask, you can ask me. Or if you need any revision class, I am ready to revise, to take a revision class. Otherwise, my course is over. के गर्ने अर्को क्लास रिभिजन क्लास राख्ने हो सिया
I don't think, sir. अब कोही स्टुडेन्टले भन्यो भने त ठिकै छ तर नर्मली नै छ सबै कुराहरू बुझेकै छन्
सबै बुझेकै हुनुपर्ने त्यही पनि कोही स्टुडेन्टलाई हैन एकजनाले मात्र भन्न त हुँदैन एटलिस्ट 5-7 जना 8-10 जनाले बुझेको छैन भने कुनै टपिक बुझेको छैन भने you can request me for a revision class.
Sure.
Okay, this was.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.